Hello there, Gore Rader with philosophyintrocourse.com. Today we are talking about validity and soundness. So, validity and soundness are very confusing, I find. Many students have trouble breaking the association between the way the term valid is used in ordinary use and the way it's used in a philosophy course. A valid argument is not a good argument or a true argument. Validity is a technical term in philosophy and logic which refers only to the form of the argument. So you'll often hear people say something like that's a valid point to mean something like you're right, but that's probably because they haven't taken a philosophy course, and anyhow for this course you'll just have to get used to this idea that validity refers specifically to the logical form of an argument. Now this is important because a valid argument can have a false conclusion, and also a argument with a true conclusion could be invalid. So a valid argument would have a false conclusion if one or more of the premises were false. Um, so we'll see there's some various permutations on how that can work. We're going to hopefully look at all of them today to help you be able to figure out which arguments are sound, which arguments are valid. Okay, so there's basically a couple definitions we're working with. A argument is valid if and only if it is in the correct logical form. So this little video assumes that you have some knowledge of how deductive arguments work and which forms are valid, which ones are invalid. If you don't, see my video on deductive arguments or some other resource that can explain that. And an argument is sound if and only if its premises are in correct logical form and all the premises are true. So there's essentially two steps to checking the validity and soundness of an argument. The first step is to check the logical form, to check for validity. The second step is to check for soundness, which means check to see if all the premises are true. This is, of course, highly relevant to doing philosophy because what we want to know is whether an argument is sound or not. Essentially, can we believe it? Should we believe it? And there's two elements to that. Are the ideas in the argument related in the right way? That's validity. And are the facts of the argument being stated correctly? That's soundness. If the elements of the argument, the elements of the ideas, are related in the correct way, if it's valid, and if all the facts are true, we have an argument that we can accept as being true. So we're going to be considering three types of arguments in this presentation. The first type is valid and sound. This is probably the simplest. A valid and sound argument is one that is in correct logical form and in which all the premises are true. So in this argument, the ordinary use of valid and the technical use line up, so that's the easiest for students to get. However, there's a couple others in which they don't necessarily line up, and those are the more tricky ones. So an argument can be valid, but nevertheless be unsound. That means it can have the correct logical form, but it can be unsound in virtue of having one or more false premises. So the ideas are related correctly, but the facts are wrong in that situation. And you can end up with a conclusion that is false in this type of scenario, but the argument is still valid. Now, a further confusion is when the argument is invalid. Now, of course, any invalid argument is unsound by definition. If the argument is invalid, then it's also unsound. But there's a couple different ways in which an argument can be unsound and invalid. And most confusingly, an argument can be invalid, meaning not in the right logical form. It can be unsound, meaning some of the premises are false, but it can still have a true conclusion. So we'll see how that works shortly. So here's our first example of a valid and sound argument. This is modus ponens form. If P, then Q, P, therefore Q. If it is raining, then there are clouds. It is raining, so there are clouds. The first premise is indeed true, that if it is raining, there are clouds. Anytime it's raining, there has to be clouds. Clouds are necessary for rain. Second premise, it is raining. It's true where I am at this moment, and therefore the second premise is true, and the conclusion, there are clouds, therefore follows. Now, the second type of argument we're going to consider is arguments that are valid but unsound. So here, our first example is similar to the last one. If there are clouds, then it is raining. There are clouds, so it is raining. Now, this is modus ponens. If P then Q, P therefore Q, which makes it valid, but unsound because we've reversed the order of the first premise to state if there are clouds, then it is raining. It is not true that if there are clouds, then it is raining. There can be clouds without rain. Therefore, the first premise is false, which makes the argument unsound. Any conclusion drawn from unsound premises is unsound itself. Alright, now here's another example of a valid argument that is unsound. If chairs are evil, then tables are good. Chairs are evil, so tables are good. Now this argument is nonsensical, but it is valid because it is in a valid logical form. This is modus ponens once again. Remember, validity only refers to the logical form of the argument. I cannot emphasize that enough. Validity only refers to the logical form of the argument. It does not refer to the truth of the premises or the truth of the conclusion. Let's consider one more example. If up is down, then down is up is down, so down is up. Once again, does not make sense, but don't get confused by the words. This is modus ponens. If P then Q, P therefore Q, which means it is indeed valid. Now, let's consider our third category, which is invalid and unsound. These arguments can have a true conclusion despite being invalid, and they can even have a true conclusion despite having all false premises and being invalid. So in these examples, the conclusion is true, but it's not true in virtue of the argument. What we're looking for is arguments that prove their conclusions to be true. We don't merely want true conclusions, because what's important is what we can show to be true. Conclusion may happen to be true, but in philosophy we are trying to show certain things to be true when we make an argument. So the truth or falsity of the conclusion doesn't matter if the argument is not good. Alright, so here's an argument that is again invalid and unsound. So this argument has false premises and a false conclusion. It is also invalid. Premise 1, the sun is black. Premise 2, my name is Jack. Conclusion, philosophy is whack. Now, we know the conclusion is false, of course. Premises are also false. Sun is not black, my name is not Jack. This argument is also invalid. It is not in correct logical form. The ideas in the premises are not related to each other in any particular way. These are just three different statements. They are not connected in any particular way, certainly not connected in the right way. The argument is invalid. It is also unsound because of the falsity of the first two premises. And of course, the fact that it's invalid makes it unsound anyways. The conclusion also is false. Okay, now let's consider another example in which the conclusion is actually true. Premise 1, roses are red. Premise 2, violets are blue. Conclusion, 30 plus 2 is 32. Now the conclusion here is true. 30 plus 2 is 32. And the premise 1 is true. Roses are red. Premise 2 is true. True as well. Violets are indeed blue. But despite having true premises and a true conclusion, this argument is not valid. It's not valid because, again, the ideas are not connected in the right way. They're not connected in any particular way. Therefore, it is invalid and unsound. Despite having true premises and a true conclusion, it is invalid because they're not connected in the right way. They're not in the right logical form. Because it's invalid, it is also unsound. So Technically, these examples in which the conclusion does not follow from the premises are called non sequiturs. That's just Latin for does not follow. Okay, so let's consider another example of a false premise, an argument with false premises, and a true conclusion. Now this one's a little more complicated. If turtles are, just because it's longer and seems more complicated, if turtles are mammals, then tigers are amphibians. Turtles are not mammals, so tigers are not amphibians. Now, the conclusion here is indeed true. Tigers are not amphibians. The first premise, if turtles are mammals, then tigers are amphibians, is false. There's no necessary relationship between the antecedent part of that claim, turtles being mammals and tigers being amphibians. Okay, now, this argument, although having a true conclusion and a false premise, is invalid. Technically, this is an example of denying the antecedent. So this argument is invalid despite having a true conclusion. So, but that argument was a little complicated, right? So how do we, if you're not very familiar with the logical forms and you can't just tell by looking at an argument like that whether it's valid or not, what you need to do to determine whether an argument is valid or invalid is write it out in logical notation. To determine whether an argument is valid or invalid, once again, write it out in logical notation. What that means is you want to rewrite the argument, replacing the various terms of the argument with letters to represent those terms. Once you do that, the argument will look much more simple. The underlying logical structure will be very clear. All you'll be left with is the structure of the argument. You're stripping out the content of the argument, the words, to reveal the structure of the argument. Once the structure is revealed, you can then determine whether it's valid or invalid. So looking at this argument, we can tell it is a conditional argument. Conditional arguments are arguments that include an if-then premise. The first premise is a conditional. If turtles are mammals, then tigers are amphibians. So let's use P and Q as our letters to represent these two phrases. So our P is turtles are mammals, and our Q is tigers are amphibians. Wherever we see the phrase turtles are mammals, we are going to replace it with P. Wherever we see the phrase tigers are amphibians, we're going to replace it with Q. And of course, if there's a negation of either of those claims, we'll replace that phrase with a not P or a not Q. So the first premise, if turtles are mammals, then tigers are amphibians, becomes if P, then Q. The second premise is turtles are not mammals. Our second premise is a denial of P. So our first premise is if P, then Q. Our second premise is not P. Our conclusion is tigers not amphibians. In logical notation, that becomes not Q. So the entire argument then reads if P, then Q, not P, therefore not Q. What was confusing when written out in words becomes pretty clear when we see it. The second premise is a denial of the antecedent of the argument, which is, of course, denying the antecedent. So a useful thing to do is, of course, memorize the various logical forms, the basic ones that you'll be using in this course. Now, it was difficult to see originally. Here it is written out again. If turtles are mammals, tigers are amphibians. Turtles are not mammals, tigers are not amphibians. You know, the negation, the not, can be confusing when you write it out. It's hard to keep track of it all. When you write it out in logical notation, it becomes easy to see what's happening. Now, here's a little sneaky trick. Say you get your argument to logical notation, but you can't remember if it is valid or invalid. Using this example, you have if P then Q, not P, therefore not Q. But you can't remember if that is a valid form or an invalid form. One thing you can do is you can write it out using a simple example that you have memorized beforehand. The example I like to use is, and recommend, is if it is raining, then there are clouds. This works for any conditional argument. So once you have your first premise, which you have memorized, which will, if it is raining, then there are clouds, you can plug in a not P. It is not raining. And then you plug in a not Q, so there are not clouds. If you can't remember whether this form is valid or invalid, when you see it written out like this, you should be pretty obvious that this is not valid, because intuitively you know that just because it's not raining, it does not mean that there are not clouds out. To summarize, here's our definitions. Once again, an argument is valid if and only if it is in correct logical form, and an argument is sound if and only if it is in correct logical form, and all the premises are true. To check if an argument is valid, rewrite it in logical notation to see the underlying structure of the argument. Rewrite the argument in logical notation, strip it down to its logical structure, and see if it matches up with the valid form of argument that you have memorized or an invalid form of argument. Now, if you can't remember which forms are valid and invalid, then you can try the sneaky trick I recommended, which is to substitute the rain clouds example or some other simple example you know to be true for the variables, so you can strip it down, substitute something simpler in there that you have a better handle on, and that can help you intuitively grasp whether the argument is valid or not. All right, thanks for listening today, and good luck in your philosophy course.